Hi, I'm Anna Hoffman, and welcome to another episode of Learn Live. Today, I'm joined once again by Bob Ward. Bob, how are you doing today?
And I'm doing great. It seems like I saw you last week, maybe.
And the week before that.
The week before that, the week before that. It's kind of been a repeating sequence. Yeah, so excited to be here today with you and everyone joining in. Talk a little more Azure SQL today about availability. Great, exciting topic, Anna, to talk to today.
Definitely. And for those of you that are joining us for the first time or haven't maybe seen the whole series, we are covering a series of modules which leads up the Azure SQL Fundamentals learning path. And as Bob mentioned, we are now on week 5, or the availability module. Bob, can you tell folks, maybe folks that have joined previous episodes or are just tuning in for the first time, like a little bit about this learning path and what we've covered?
Yeah, think about that journey 5 weeks ago. We tried to make sure we got a level set, a foundation for you of what is Azure SQL, whether it's SQL Server and Azure VM, managed instance Azure SQL database, and all the various options you're going to be using, just to make sure you understand terminology, Azure ecosystem, things of that nature. And then you have to deploy this first to start to use it. So deploying configuration being a great topic we covered in the second week, comparing that to a SQL Server experience, and then that meat and potatoes, right? We started with security, last week did performance, and this week availability. None of one of those were a specific ordering, a priority ordering, because you really need all three, quite frankly, to be enterprise ready. But availability being that third topic in the meat and potatoes. And then next week will be a really fun discussion where we'll kind of put it all together and wrap up this entire series.
Yeah, next week will definitely be interesting. So people will have to tune in. They'll want to tune in because it's going to be the most interactive session. We'll have to figure out how that goes.
Yeah.
A few references you'll see on the bottom left and bottom right. That first one on the bottom left is going to be to this learning path in Microsoft Learn. And the second one on the right is a link to a bunch of resources that our team puts together related to SQL. If you select the Azure SQL Workshop, then there's a whole repository that includes the slides that you're seeing today. But today, like Bob mentioned, we're going to be talking about the availability module, and you can find that at the link aka.ms/learn Azure SQL. This is a really great resource because it allows you to get hands-on with Azure SQL services and other Microsoft services for free for a limited amount of time, but as many times as you want, essentially. So definitely go check that out afterwards. Most of the demos you see today are coming straight out of this Microsoft Learn module. We also want to remind you all that this is live and interactive. So just like all the other weeks from wherever you're streaming, we do have SMEs, or subject matter experts from our team, standing by to help answer your questions on the chat. We want to encourage you to ask your questions on Learn TV because that's where our SMEs are monitoring the most. So head over to Learn TV and be sure to interact with us, whether it's a question, a comment, something slightly related or a tangent, or you just want to say hi. We'd love to hear from you and interact with you. And of course, you know, Bob's favorite part is going to be the knowledge checks that we have. So we'll look for your engagement on those.
Yeah.
So without further ado, let's get into the module. We have a lot to cover today. So we're going to see how much of this we can get through in 90 minutes. I'm just kidding. We're going to get through all of it. It's going to be a lot of fun. So I'm going to get right into it with availability, capabilities, and tasks.
You know, Anna, if you remember kind of how we've done these last modules, we have our breadcrumbs right at the bottom, which are kind of the sequences of what we're going to do in the module. So as you're following along, look for the dot, the blue dot of where we are in the sequence, but you can kind of see ahead of where we're going. But this pattern is kind of how we molded a lot of the things in the last 3 modules for security, performance, and availability. We want you to understand what the capabilities are, so you see what's possible, and then what are the tasks you need to complete to ensure that your Azure SQL deployment is highly available. Now, this is one of the richest areas we have in these 3 sections about capabilities. Why is that? It's because we're using the power of SQL Server, but we're using the power of Azure. A lot of built-in capabilities come for availability, a lot of options for you to make it more highly available. Therefore, you're going to spend more time seeing capabilities here. And they include all sorts of things, right? Like, how about automatic backup restore? Or even in some cases, your ability to control that yourself. Or how about built-in HADR and read replicas? How about going further with availability zones, geo replication, and failover groups, even further just in a single instance type deployment? And then there's some interesting discussions towards the end about comparing just overall availability topics and database consistency from SQL Server to Azure SQL Database and Managed Instance. Now, Anna, replication is listed here as a capability, and I call that out specifically. We're not going to have a whole slide on that, but you need to understand a lot of people like transactional replication, and that full capability exists on Azure SQL Managed Instance. You can go and set up a full transactional replication environment. And a lot of people don't know this, but an Azure SQL database can be a subscriber, both from a managed instance or even from a SQL Server on-premise environment. So replication, that rich feature that you've known and loved for years, it is available in Azure SQL. We didn't really cover all the aspects of that because it really is just the same of what you might be doing in a SQL Server environment. Now, once you understand these capabilities, what kind of tasks are you going to do? It all starts with recovery time objective and recovery point objective. You decide what those requirements are. And we're going to have something later where we're going to help you a little bit pick some of that. You're going to go pick what we call the addition. This is a combination of like service tier and availability zones and various type aspects in order to get the right RTO and RPO requirements for your business. Then you're going to go configure HATR accordingly. You may set up availability zones or geo replication or something of that nature. And then you want to monitor. You want to monitor various aspects of availability. We'll certainly show you that. So Anna, that kind of sums up what are the capabilities and kind of what are the tasks you're doing, and the rest of this module follows on the sequence of those topics.
Yeah, I think it's going to be a great module, Bob, and we're going to get hyper focused, and I know you're going to really enjoy it, and so will everyone else. Okay, so let's get right into it, talking about backup and restore. Now, this is something that we get asked pretty frequently about when it comes to, okay, I've moved to a platform as a service, where are my backups and what's happening? Well, the great news is that we're taking care of a lot of this for you. So typically we run a full database backup once a week with log backups every 5 to 10 minutes. Additionally, we have diff backups that are every 12 to 24 hours, and you get to choose where your backup files are stored. Now, the default option is usually that RAGRS, so read, access, geo-redundant storage. And what that's going to allow you to do is basically if an entire region goes down, this means that your backups are available in another region and you can perform what's called a geo restore. So right off the bat, you're kind of protected against the whole data center going down. But recently we also added options if you maybe for reasons where you want to keep all the data in one region, you don't want to do this. So we have options around locally redundant storage as well as zone redundant storage. And we're going to talk a lot more about zone redundancy later in the module, so you might get a better understanding of why you might choose this type of offering. Now, occasionally we're also going to run backup integrity checks. So what this means is occasionally we're going to perform a full database restore on your database and make sure everything's running according to how it should be. We're going to run some tests and that sort of thing. And additionally, we have this ability to do a point-in-time restore. Now, this is something many people are familiar with from SQL Server. A few big differences. The biggest is that you can restore to a point in time, but you cannot restore in place. So this means you're going to be restoring to a new database. And really, we do this to protect you. So you restore to a new database, make sure everything is the way you want it to be, and then you can go through a renaming exercise. I actually have an exercise in the module where you can go through this yourself. Additionally, we support long-term retention. So this means if the standard length of retention, that's up to 35 days typically on most deployment options, is not long enough for you, you can actually choose on SQLDB and Azure SQL Managed Instance in public preview to store these backups for up to 10 years. So that's a big thing that customers use. You can even use this if you have deleted databases. You're able to restore your deleted databases from 5 years ago if you have long-term retention set to 10 years, for example. Bob, what's the significance of what we're doing here?
Well, Lena, as you know, spent a lot of time in support customers for enterprise customers for years, and no one really ever called me and said, hey, Bob, I'm really happy right now. My backups are working. My backup restore system is amazing. I'm just really excited, right? It was usually, I can't restore backup. I'm really in trouble. And so we would talk to customers, and I've actually visited customers on site about how to set up a system to do everything that you're seeing right here. This is not trivial. If I told you that I could help you just by deploying in our ecosystem with Azure, I could have automated backups like this. I could have the backups redundantly stored, even in different regions around the world. I could have a self-service point in time restore through the portal. I have integrity checks automatically run. I could keep these backups for 10 years. And anytime I deleted a database, I could just go to the portal and pick and restore it. And if I had told you I gave you all of that, and just by clicking a button and deploying Azure Database, you might want to sign up for that. So, I mean, a lot of people have struggled to build systems like this, and this is a big part of what we're providing with a lot of automation from a platform service perspective for Azure Database and Managed Instance.
Awesome. Yeah, definitely. And it's great to have that perspective of someone who has seen the other side of this automatic backups and restore capabilities. So I thought it would be interesting to take a look at one of the exercises in the module. This is actually a point-in-time restore. Sometimes you'll hear people call it PITR, but point-in-time restore demo. Full warning, I did pre-record this because sometimes it takes a few minutes to restore the database, and we don't want to just sit here staring at it because we have lots of demos to get through. So I'm going to kick this off. What you have here is my AdventureWorks database. So I'm just running a simple select statement, and then we're going to simulate an accidental drop of a table. So let's say somebody accidentally drops a table. I'm just going to make note of when that drop happened. In the exercises, you'll actually go deeper into this process. But for now, we're just going to manually put in the time for when we know that table was dropped. We're just going to set that as the before error time and kick off the AZ SQL DB restore. We're going to specify the database name copy. So like I said earlier, you can't restore in place. You have to restore to a new database. So we're just restoring to AdventureWorks-copy of the AdventureWorks database to the before error time. So that's really all that AZCLI command is doing. Now, this does take a few minutes because what we're actually doing is restoring your entire database. So if it's a very large database, sometimes that can take a little bit longer. But what you're seeing here is we can see that the database is in fact restoring. You can also see what I mentioned about the AdventureWorks versus AdventureWorks copy. Now, once this completes, what we'll be able to do is basically confirm that we now have the before error time. So confirm that we do have that table that was dropped accidentally. So sure enough, we do have that table. So I can go back to Azure Data Studio. Again, this notebook is available in the module, but what we're going to do now is just go through a simple renaming exercise. So we're going to rename the copy database. Sorry, we're going to rename the original database to AdventureWorks-old. And then that's going to allow us to rename the new database from AdventureWorks copy to just AdventureWorks by itself. And now we're basically back to our starting state. So, of course, we were down during this time where all these changes are taking place, but this is going to make it a lot easier for you to manage that because it's just a few commands. And since we're going through this renaming exercise, you won't actually need to change any connection strings. So once this refreshes, you'll be able to see we do have that AdventureWorks database. We also have the old one, which we could delete if we wanted to. So that's a really simple exercise, but I think a powerful exercise that shows you the power of point-in-time restore. So definitely recommend you go try it out on the in the modules themselves. All right, so the next thing we're going to talk about, we talked about backup and restore. Kind of the next thing in our breadcrumbs, as Bob calls them, is we want to take the service tiers and take a look under the hood at actually the architecture that you're getting when you deploy these service tiers. And you've probably heard us allude to this throughout the modules and the learning path, but I think here is really where you're going to get to see what's happening. So first, we're going to talk about general purpose, and this is going to be the same across managed instance as well as Azure SQL Database. If you're familiar with SQL Server, then you're probably familiar with a failover cluster instance, and this is going to behave very similarly to that. So let me just take you through the architecture, and we'll see what I mean by that. So firstly, we have an application. Now, regardless of what service tier, you're going to have an application that's going to the gateways in the control ring, which is basically going to tell the application how to connect and where to connect. And that depends on, if you remember in module 2, we talked about redirect versus proxy, and that's going to change if you're going to the gateway every time versus then going straight to, in this case, the primary replica. Now, for general purpose on the primary replica, we have, of course, the TempDB running on directly attached SSDs. However, your data and log files are stored in Azure Premium Storage, and that storage is also locally redundant storage, or LRS storage. So you can think of this similar to a failover cluster instance. Again, your backups are going to be stored depending on what you choose, but typically by default, people store them in GRS storage. Now, when a failover occurs, what happens? Well, we're going to look for a node with spare capacity. We're going to fail you over, and then we're going to redirect the pointers back to the data and log files. And then we're also going to take care of redirecting you connecting to, say, the database name back to this actual primary replica. So this takes a little bit of time just because we have to look for a node with spare capacity and then fail you over. So we'll look at some other options and you'll see why they might be faster. But the cool thing is connectivity redirection is built in, and you've probably heard us say this a lot of times already, but I'll just say it one more time. Having retry logic in your applications is super important, because if a failover does occur for whatever reason, maybe the node is unhealthy, we have to fail you over, you don't want to enter this downtime because your application hits it and it's offline for, just a millisecond or one try or that sort of thing. You want to be protected against that, and that's why retry logic is so important. So that's the general purpose high availability architecture. Bob, is there anything you want to add to that?
No, I think the thing that's just really critical to kind of emphasize what we talked about with backup, if you look at this diagram, your data files and log files are on redundant storage in Azure. So there's copies of your database already. Their backups are on a different set of storage, and there's copies of those. So, and then we have our replicas that can be used for failover, again, like an instance. So we've given you abstraction to your connection. You don't have to worry about that, right? The app automatically, like you said, with a retry, the gateways redirect you wherever we're going to go. But your data is all redundant. So it's really powerful capabilities just for general purpose alone. That's just built into the platform. It's pretty powerful. And it kind of leads to the discussion about business critical. So if general purpose is like a failover cluster instance, what is business critical? Well, it's similar, but we're going to use the power of always on availability groups, our tried and true flagship HADR capability, using replicas we've had for SQL Server for several versions. Now, the app is still connecting to gateways. It's still going to be used for that redirection capabilities. And you have a primary replica, just like general purpose. But notice here in the primary replica that on the SSD attached drive is your data and log. Now, TempDB is also there. We just don't show that. But your data log are here versus being in Azure storage. And what we're going to do, just like an availability group, we're going to keep secondary replicas. We're going to create them when you deploy a business critical database or a business critical managed instance. And you see here, you have your secondary replicas and the data, of course, on local drives there. Now, we keep 4 replicas available at all times, but just like general purpose, those backups are going to be at a different location using Azure storage. As Anna said, the default would be Geo, but you can change it, make it local. But the key is it's redundant. Now, stop, look at this picture for a second. I have redundant storage again, like I had in general purpose, but I'm using replicas for data and log redundancy, and I'm using Azure storage for my backup redundancy. Now, just like availability groups, you want to make sure you're synchronized, and we have to do that to be able to fail over. So we're going to make sure that at least one of these replicas can harden the log change before we're going to come back to the transaction and commit it to ensure we can do a failover. And what happens, like in general purpose for failover, it's a very similar process where we're going to coordinate SQL with Service Fabric, just like general purpose. But notice the difference here. Because of the fact we have a replica, failover is much faster. We don't have to spin up another primary replica or compute to go then attach to Azure database. We already have been redoing log changes here, right? So all we're going to do is fail over to one of these replicas that isn't synchronized. And here's the cool thing. Your connection, your abstraction with the gateways is automatically redirected to this new primary. Recovery time can be extremely fast here. We're already redoing changes, and we're going to take advantage of accelerated database recovery, which we'll talk about later in today's module, is on by default these databases. So the recovery time in failover can be extremely fast. And here's the other benefit. Just like you would when you would set up your always on availability group, one of these replicas can be a read replica for you for free. So you deploy business critical. Behind the scenes, we're going to put AGs for you on there, make faster failover time, hence business critical. We're going to put backups in different locations, but we're going to also give you, Anna, the ability to have a read replica. And Anna, you're going to use that same concept of read replicas like you do in SQL Server. Use application intent read only with the same gateway connection strings, and you're often running either using your read replica or using your primary compute.
Yeah, definitely. And it's really powerful, I think, that you can just, just to be clear, like you're not configuring anything. You're just deploying business critical and you're getting all of this.
And I
Same
should
with
comment
general
there that,
purpose.
we show these slides for a reason, to show you what is going on behind the scenes so you know what the capabilities look like. You just remember what we just said. You just go deploy a database, GP or BC, and you just get this. But we think it's important to kind of show you what's possible so you know why we say you're so highly available. And it explains why we can do these service level agreements, which we're going to talk about later.
Yeah, definitely. And, we thought it would be exciting. And this was actually, I think, Bob, maybe you came to me and said, I wonder, the failover time should be faster. I wonder if it actually is. And I said, oh, well, let me go see. And so this started this experiment. So let me just hop over to my virtual machine and show you guys this example. This is Azure Data Studio. So there's a lot going on here. What I have that you want to be aware of is that the left side, everything on the left side is going to represent a general purpose database. I have this hooked up to a general purpose AdventureWorks database, whereas everything on the right side of your screen is hooked up to a business critical AdventureWorks database. So the same data in the databases, just different databases, different service tiers. Now down in the bottom, what I'm doing is I'm actually using OStress to just do a simple query and on the business critical database here, and the same query over here, but on the general purpose database. Now, this is really just a simple query that's just querying availability. So if you see the number 847, it means that that database is available. So right now on the left side, the general purpose database is available, and on the right side, the business critical database is available. Now, what we're going to do is you can actually use Azure PowerShell commands to force a failover. Now, you can only do this once every 15 minutes, so we don't want people taking advantage of this capability. But it's an interesting experiment to kind of see how fast is business critical failover versus general purpose. Now, before I kick this off, we would expect that business critical would fail over faster because we already have a replica basically standing by. So this redirection and reconnecting you to the right database should be a much faster process. So let me kick it off and just monitor the availability of each database. Remember, right is business critical, left is general purpose, and we'll see how the demo fares. So immediately you saw this business critical database become unavailable. And like I mentioned, what we're going to expect to see is that it's going to fail over much faster. And it looks like it failed over in about 5 seconds, whereas this general purpose database is still going to fail over pretty fast. However, it's going to take a little bit longer because we don't have an availability group behind the scenes, because we're looking for a node with spare capacity and then we're failing you over. Now, in my experience, the business critical database usually fails over between 2 and 8 seconds. I think one time, Bob, we were actually doing something when it was 2 seconds and you were like, that was awesome. And then the general purpose database, we can see it's back to being online as well. It typically takes around 30 seconds. So it's still pretty great because you just deploy it and this is what you get out of the gate. So that's general purpose and business critical, which are available in both Azure SQL Database and Azure SQL Managed Instance. And we usually talk about the vCore model, but this same architecture is what's used underneath the hood for the standard and premium in the DTU model as well. However, Bob, in Azure SQL Database, there's one more service tier. Can you tell us all about it?
Yeah, let's talk about Hyperscale. So Hyperscale for Azure SQL Database has a fairly unique architecture for a very specific purpose, and that is we are out to give you high scalability and large database sizes. And we have to use an architecture in Azure Platforms as a Service with a database to give you that. So it all starts like this. If you look at this diagram right here, we're going to show you, you're going to have compute or replicas like we mentioned in the other diagram, and you're going to start with a primary compute node. And it's going to be running a SQL server, just like it is in a business critical general purpose. But there's one interesting difference about this SQL server, and that is the fact that in this SQL server for this compute node is something called RBPX data cache. Think of this a little bit like buffer pool extension, which we released in SQL several releases ago, but a lot better. And so this represents an SSD drive effectively. And so when you're going after on this primary compute data pages for your database, we expect if possible, as much as possible, to get those pages from either the buffer pool of the primary compute or from the cache. All right. Now we'll talk about secondary computes in a second and how that works. So let's say that you have a huge database and we cannot fit, based on how you provision your vCores, your pages, you can't find them in the buffer pool for compute or in this cache, this SSD drive. So what we have something called our page servers. This is part of what we call a tiered architecture. These, again, are SQL servers that we've architected so that if the SQL server in the primary compute cannot find the page there, it will issue an IO request to this page server. And there are several page servers depending on the size of your database. It too has a buffer pool and an SSD cache. So you can see already here that our objective is for very large database sizes, we're going to use this tiered architecture. You may be asking, like, well, why would you do that? Okay, so what? I've got a 50 terabyte database. Why do you need this? Well, in order to support databases of that size, we're going to put the data and log actually in Azure storage, not in local drives, Azure storage, your actual database files. But you may be asking yourself, well, that's not very fast. But remember, we are mostly serving your data needs from this tiered architecture. We're feeding, and we'll show you in a second how this works. We're taking changes and updating these caches along the way so you don't have to go to the actual data file in Azure storage. It's pretty cool. Now, we'll talk about why it's important, though, to also have these data files in Azure storage in a second. When I first was doing this diagram, Anna said to me, like, there's one piece missing here, Bob. Like, what about the transaction log? Well, as it turns out, SQL servers had the capability for years to the engine itself to refer to transaction log that's remote in Azure storage. And as it turns out, our transaction log in this model is in Azure Premium Storage. We call that the landing zone. Now, we also have a separate log service, a compute node, that is going to look at this landing zone here and take changes and apply them to page servers and to secondary replicas. It's not using the exact always-on availability technology, but similar. The concept being is that let's take changes from the log and apply them to keep our caches refreshed and the secondary replicas refreshed as well. Now, for long-term storage, though, because for point-in-time restore operations, you need to keep it for a long period of time, we will push log changes as they age into long-term standard storage for Azure. Pretty cool architecture already. You can see how we've actually implemented something in the log and a tiered set of page servers. Now, the reason we put these database files in Azure storage is very important as well, because we can use a technology called snapshots. So actually taking a snapshot of this database backup is very, very fast. It also allows us to do a point-in-time restore very quickly. And we've been able to demonstrate terabytes, like how about 50 terabytes in 5 minutes, that kind of type speed to do a point-in-time restore. But that's not the only cool story about this. And when we were first talking about this whole idea here, you can do failover just like you can do in the other tiers because we're applying logs to these secondaries. But I put on the slide 0 to 4 secondaries. And you told me we're having this discussion about reviewing. You say, Bob, I think you made a mistake. Surely you meant 1 to 4 replicas. You remember that conversation, right?
Oh, yeah.
Yeah, and I was like, hey, actually turns out 0 is correct. And here's why. The data files are in Azure storage, right? It's almost like a general purpose service tier. So I don't need a replica to do failover. All I need is to be able to get access to those data files and spin up and use my page servers to replenish another primary compute that you would spin up. But my failover time is going to be slower. So if I spin up replicas, my failover time will be faster because those changes have been applied from the log service. So this is why I get this idea of 0 to 4. But remember, in business critical, we only gave you 1 read replica in this environment. Now you get up to 4 secondary read replicas for purposes of failover and for read scale. And so again, that recovery time for here in Hyperscale is going to depend on the existence of these replicas. And you kind of think of this as kind of the best of both worlds. It's kind of the best of a general purpose type architecture, separated data in Azure storage, but also in that business critical mindset. So recovery can be very failure if you decide to put replicas in this environment.
Yeah, it's definitely a super interesting architecture, and I think you're spot on. It's interesting to think that, at least I would think that maybe the failover time if you have 0 replicas would be more like general purpose, because I know we didn't include that in the demo. And then for business critical, if you have more than 1 or 2 secondaries, I would think maybe Hyperscale would kind of behave like business critical. Is that a fair thing to?
Absolutely. Absolutely. Because these secondaries are getting log changes applied to it, just like you would do from an availability group. We're not using that exact technology, but the log service is keeping those things up to date. And in addition, Anna, within this, we talked a little bit of this in performance last week. We have services that are monitoring this entire environment. And if necessary, we might throttle log changes to make sure everything is kept up to date so that failover will be fast and maintain our service level agreements.
Awesome. That's pretty cool. One other thing I wanted to call out here, and I think I had mentioned it before, it looks like you might have had a typo on that SQL Server XC. Do we need to update that?
No, Anna, I'm sorry, but this predates you as a person. But when SQL Server was born, this was the MS-DOS days. Do you even know what that is? Oh, yeah, you saw that in the Smithsonian one time. I remember, actually, yeah. So in the DOS days, you had 8-character limitations dot file extension. SQL Server spelled out as more than 8 characters. So we first created the product. We had to put it as 8 with the missing the E. Anna, I can't even begin to tell you, that would be mutiny if I ever suggested to our engineering team, hey, can we actually make that a 9-character thing? Like, I don't even know if the product would function anymore. But yes, it's a legacy of OS2 and MS-DOS days when you had this 8-character limit.
Very interesting. I guess it's just going to stay like that forever.
It will stay like that forever. As long as you and I, for the rest of our lifetime, yes, it will stay like that forever.
Awesome. Cool. Well, Hyperscale is super interesting. I thought it'd be interesting to take a look at a demo. Bob mentioned you could have 0 to 4 readable replicas. So let's take a look at, how that actually plays out in a scenario. So what I have here is I have an application that basically inserts a certain number of events per second, as many as we can. And this is a Hyperscale database, so it's able to insert, it looks like around 14,000 events per second, and we're just going to keep trying to kind of insert events. Now, what we have on the right is SQL query stress, and I'm just using this. This is a read query. It's not writing anything to the database, but I'm running it on the writable or the main primary endpoint. And what you can see is when I execute this workload, what happens is my primary takes a hit because, we're sharing the same replica as far as compute goes. So what's very interesting, and you can see we're going all the way down, it's like 11,500. This is just an average. So what we can do is we can scale up our readable replicas to 4, and then we can go back, and I actually have 4 other SQL query stress windows, just 4 to show we're doing the same workload. Primary events per second. Again, this is just an average, but you can see it doesn't take the big hit like it did on a quarter of the workload when we were running against the primary. So I think it's a pretty powerful example. You think about all these different things that are happening these days, especially HTAP and things like Azure SQL Database, and this can become a pretty big deal. And you can scale these out on demand. So you can say, hey, we're going to run a bunch of reporting or something like that. I'm going to scale up to 4. And then when you're done, you can say, well, I don't really need these anymore. Depending on my availability requirements, I might scale back down to 1 or 2. So that's Hyperscale. Now, fun stuff. We're going to head over to some knowledge checks. This first one is actually pretty tricky. I will give that warning. So be careful. We have had some questions come through on the teleprompter, so maybe we can use this time.
Well, we better, because once again, you've created something tricky. What a shock to everybody.
What a shock.
Yeah.
So
yeah, you got a question? You have some questions?
Yeah, it looks like we have one question. Bob, maybe you might be able to take this one.
Okay.
This question seems a bit more general, but it says what are the problems or potential problems with continuous replication?
Yeah, I don't know if it's necessarily a problem per se, but the one thing about a business critical environment or even something like Hyperscale is we do offer higher log rates there. We actually do that on purpose because we know you're pushing a lot of changes through. But because you're using a replica type environment, a log change environment, there could be performance impact, performance ramifications to that, right? So like if you push a certain number of log changes through, we got to make sure we meet our service level agreements if those failovers get very, very quickly. But the good news is that our log rate algorithms and our limits are higher in those spaces than general purpose. And we knew that. We knew that we have replicas to keep going around. So we don't want to put those log rates lower because that might impact performance of your app. So I think actually what could appear to be a problem doesn't actually end up being a problem because of the fact that we set those limits higher.
Awesome. Thanks, Bob. And hopefully that helped with the question that came through. Let's see. Oh, I'm seeing some results coming through now for this question. Maybe we can go ahead and take a look at it. But just to kick it off, the question is, which service tier puts the data and log files on Azure Premium Storage? And looks like we have been able to trick quite a few people, because currently about 50% of folks are saying all of the above. So Bob, can you take folks through it and maybe kind of help them out along the way?
Yeah, remember, Anna, how we've kind of treated this before. It's kind of my personal own technique to do a process of elimination. Like I try to go figure out what not the answer is and get down to the point of what are my choices left and figure out what I think the best answer is. So yes, of course, you did a tricky thing. Once again, what a shock. The professor that everybody, loathes to get because she does tricky pop quizzes on us, right? So, oh, I'm sorry, and I make fun of you each week saying that, and you're actually a great professor, but you do make these tricky, man. You do this. Okay, anyways, service tier puts data and log files. We're talking about database and log files on Azure Premium Storage. Let's just put out there that you said Azure Storage. This eliminates B, because we said in Business Critical, the data and log files go on a local attached SSD drive. This also eliminates D, because obviously if B is not an answer, you can't have all of the above. So it's going to be A and C. We specifically showed you just a diagram where the data and log files for Hyperscale are on Azure Standard Storage. There's the tricky part. But for general purpose, and again, let's emphasize why that is. We can get away with that because we don't have to go after those data and log files except we do a point-in-time restore, but that's with a snapshot. So don't worry about the performance of Azure Storage for your data and files on Hyperscale because we don't really access them ever. But for general purpose, we do need to access them, right? There you go. And so we need to put those data log files on Azure Premium Storage. So therefore, the answer is going to be general purpose.
Awesome. Yeah.
Did I get it right?
Yeah, you got it right, Bob. So well done. I think we might have lost a few people because we only got about 11% of people saying general purpose. So okay. I think your explanation probably really helped. Hopefully help people get it straight.
Okay.
Now we have one more question, chance to redeem yourself if you got the previous question incorrect. This question is, which service tier has an always-on availability group deployed behind the scenes? So hopefully this is a little bit more of a straightforward of a question. While you guys take a stab at answering this, we did get one question in. Okay. And they say, does Azure Managed Instance get automatically scaled when it reaches its 100% storage?
Yeah, the answer to that question is no. Hyperscale does. In fact, there is no 100% storage. With Hyperscale, you don't even pick a storage limit. You just say, I'd like a database, and I'll hear some cores, and we just start giving you storage, and you just keep adding to it. For Managed Instance, though, you pick a limit. Now, one thing it's important to know about that limit, you have a possible limit with Azure Managed Instance for storage for all databases. Possible is based on your service tier choice. Right? You get like 8 terabytes for general purpose, although we're even considering Anna increasing that. And you get 4 terabytes for business critical. So that's the possible limit. And then you pick what is your limit within that is what you get charged for. So you don't have to pick 4 or 8 terabytes, but those are your possible limits. But yeah, when you reach 100% storage with Azure Managed Instance, you get an error. And then you have to go manage that at that point to decide. But we don't scale anything. But keep in mind that if you have a 8 terabyte general purpose managed instance system and you pick 4 as your limit, and then you hit that 4, you can go then scale up pretty simply, to this 8 level if you'd like. But we don't dynamically change that.
Awesome, thanks, Bob. Hopefully that helped answer your question. We got one more question that said, is there availability for the DTU model, specifically the basic and standard tiers?
Yeah, they deploy a similar concept like general purpose, right? So it's going to have that same feeling. We always want you to be available, right? And when you're using Azure itself, so it's going to feel more like the general purpose scenario.
Awesome, great. Okay, so let's come back to our poll.
Okay.
And it looks like we have about 65% of people are saying B, business critical. So Bob, can you take us through it?
Yeah, so process elimination, right? General purpose is not it, because we just showed you that we use Azure Premium Storage, and you specifically said, Anna, it's like a failover cluster instance. So A and D are both eliminated, it leaves B and C. And I specifically said for Hyperscale, we use log replay type technology, log change technology, but we don't deploy it always on availability groups specifically to do that. Therefore, the answer has got to be B.
Exactly.
And then one of the ways to know that, remember we talked about last week that you could see some weight types that you see during an AG deployment with business critical, even though you didn't set up the AG, we did. That's kind of the reasons you know that we deployed that technology. One quick tricky thing I'll say, okay, is that if you use like Geo Replication, we may be using some of these technologies, even like in the general purpose scenario. So technically, somebody could come along and say general purpose with GeoDR or something. But I don't think anybody was probably thinking that in their GP answer. So
maybe I should add that as another option, so we keep it tricky.
That would really, yes. Why not? Why not, Anna? Make it harder. Sure. Yeah. Good job.
Okay, thank you all for participating in these polls. It helps give us a tab on how you guys are doing, and if we need to like clear anything up or anything like that. So we've talked about the high availability for different service tiers, and now we're going to talk about a few ways that you can opt in to potentially take that availability a little bit further. So we're going to talk about something called zone redundancy, and we'll start by talking about business critical. Now, if I think first, if I take a step back and talk to you about what is a zone redundant type of database, or what is an availability zone, as you'll also hear us call it, we'll also call it an AZ. So an availability zone just means it has its own separate heating, cooling, water, power, that sort of thing. So it's more granular than a region. So in a region, if your region supports availability zones, then there's going to be multiple of these kind of independent units, and that's going to protect you from, for example, if a whole building goes down or something happens to a building and the power in one building, there could be somewhere else in the region or the data center, another place where your data is going to be stored. And this idea of having availability zones or using AZs to create what we call multi-AZ deployment, it is not just an Azure SQL thing. It's something that we're seeing across many data services and storage services in Azure. But the first one that zone redundancy came to is going to be the Azure SQL Database Business Critical tier. And so if we think about how this works, what you're seeing here is AZ1, AZ2, AZ3. So these are, again, separate power, heating, cooling, water, that sort of thing, each one of them. And so your primary replica is going to be in one. And then what we're going to do is, since you can, again, have an availability group with business critical, we're going to basically spread the rest of your replicas out across different availability zones. So in the case, and of course your backups are still stored in Azure Standard Storage, but in the case that a failover needs to occur because an availability zone goes down, we can very quickly fail you over to one of your other secondaries that's sitting in a different zone. Now, one thing to keep in mind is that you don't have visibility into any of these availability zones. You're simply connecting to your database, and it's going to connect through Azure Traffic Manager to point you to the right control ring of gateways and then get you connected to your database. So this is really nice because you kind of get all this built in, and this is free for business critical and premium service tiers. And this is just going to help keep you protected against zonal outages. So that's business critical. And if we look at general purpose, we recently came out with a preview for this, and that preview came first for your provision databases, and even more recently, I think just a few weeks ago, for your serverless databases. And this is going to help keep your database, again, resilient to zonal outages if it's a general purpose database. Now let's look at how this works. It's a little bit different. So since you don't have an availability group, what we're actually going to do is use your Azure Premium, your data and log files, and spread those across Azure Premium storage accounts that are in different availability zones. So you already have this redundancy before. It was just locally redundant storage, and now we're spreading it across multiple availability zones. Again, you can choose to have your backups in geo redundant storage, but now that you know the different types of storage, you could see you could also choose to put your backups in zone redundant storage, and we are seeing customers do that. Now, when a failover happens here, again, it could take a few seconds longer because what we're doing is we're going to look for a node with spare capacity, and then we're going to point you to your data and log file that's available in that availability zone because you've spread across multiple availability zones. So this is another way to keep you more highly available. And one thing to keep in mind is that this service is not free because by default, we aren't doing this zone redundant replication of your data and log files in the general purpose service tier. So those are the two main things related to availability zones. Bob, anything else you want to add about availability zones or connecting to services like this?
Yeah, absolutely. I mean, I think one critical point you just said, that you declare that you want this, right? Like when you deploy or later you say, hey, I'd like to be a part of an availability zone with your Azure database. But we show these architectures again because just we're doing all this behind the scenes. You just say you want it, we give it to you, and you see the power of what happens. The other thing is that Azure Traffic Manager, we just do that automatically. There's no app logic here for you. Your application, remember we talked pretty importantly about general purpose and business critical and Hyperscale as well, where the application uses the gateways to get redirected. Well, now Azure Traffic Manager talks to the gateways to direct you, and your app logic is free from worrying about that. So we show these architectures again to show you what's possible, why you get more availability, but a lot of this just happens behind the scenes because you declared you want to be part of zone redundancy.
Definitely. And this all kind of plays into something called a service level agreement, or SLA. And maybe folks have heard that term thrown around before, but Bob, can you tell people what that actually means?
Yeah, I mean, it's really cool what we built, right? And so you're looking at this going, wow, I think I could have a pretty highly available application and run my business on this, right? But like, does Microsoft put their money where their mouth is? Turns out we do when it comes to availability. So we have links for in the slides here, and in our resources at the end, we show you how to get these decks. You can click on it, but you can just search for this. Anna, you can say SLA for Azure SQL, and you'll come to an actual service level agreement contract that we publish on the internet. So when you go deploy as part of your description in Azure, we make a promise, or we pay you back Azure credits if we don't meet this, what you see here. So first of all, look at this left side. This is about availability in something called nines or uptime. You may have heard this in the industry, kind of a common terminology for uptime. So for basic standard general purpose, now again, we do have multi-zones for GP in preview, but we haven't added that necessarily to SLA because it's not generally available yet. So for general purpose, for example, because you have single zone today as GA, this is your uptime. 4 nines is basically what we call it. For business critical, it becomes 4.9. But notice if you go to zone redundancy, this becomes 99.995. Anna, did you know that's actually called 4.5 nines? And you might be interested to kind of translate that. It's about 2 minutes a month of downtime. So we're only giving you, we're promising that you're only going to have 2 minutes a month of downtime on average across the year if you'll go to a business critical in a multi-zone deployment. And then it's interesting, Hyperscale right here, notice this one. We said as you get more replicas, you're faster and you're more available, and our SLAs kind of back that up. So if you go to 2+ replicas, you're going to have more availability and an SLA than you would if you had like 0 replicas. So that's kind of like your SLA from a nines perspective. Now this right side's interesting, Anna. We're the only database in the cloud industry today that offers and promises RPO and RTO as part of an SLA. Now you'll notice here, we only do this today for business critical, and you must use Geo Replication or auto failover with business critical. And if you do that, notice our SLAs, 5 seconds for a point recovery objective and 30 seconds for recovery time objective. That's pretty snappy. So again, look at SLAs. You can look what we publish on the internet about it and your contract. You sign up for a subscription, you deploy it. You don't go have to pick anything. Just by deploying it, you're getting the promise of what we show here on this slide.
Yeah, I think it's pretty powerful. And, if most people go ask, their local center what their RPO and RTO is, a lot of times it's not going to be what this is, and you didn't even really have to do anything to get it.
Right.
So pretty cool. We actually haven't talked about GeoDR, like you mentioned, Geo Replication or auto failover groups. So I thought it'd be a good opportunity to kind of just cover that. Now, there are differences between these, kind of a lot of differences, like why you might choose one versus the other. So I created this chart that basically compares things for Geo Replication versus auto failover group, and then the blue is what might be preferred. So for example, Geo Replication supports having your replicas in the same region as your primary. It also supports having multiple databases being replicated. So you might replicate to East US, East US2, somewhere in Southeast Asia, the UK region, all these different regions you can have multiple of, and you can use all of them for read scale. So you can kind of scale where your app users are, people running reports are. Now, something to be aware of with Geo Replication is it's not supported for Azure SQL Managed Instance. And there's no aliasing over top of it by default. So you do have to update your connection string after a failover. Now, with auto failover groups, some of the things that you get that might be representative by the name is you are able to do an automatic failover if something goes wrong, or if you want to force a failover, and you don't have to change the connection string because you are just connecting to the failover group read-only listener versus the read-write listener. Some things to be aware of, though: you cannot have multiple of these, just one failover group per server, and it can't be in the same region as your primary. So that's just some things to keep in mind. For people who are more visual learners, Bob, can you tell us how it kind of displays itself in the architecture?
Yeah, I'm a very visual person. I love these diagrams and so forth to kind of talk through it. And if you go deploy Geo Replication with Azure SQL Database today, for example, it might look something like this. Notice here and you mentioned before, just to be clear here, you could do Geo Replication in the same region. We're showing this across regions, though. And the idea being, though, you have a database here using Geo Replication to another logical server in another region, right, in this particular case. And your read-write traffic is going to this primary. But you could do failover, right, to a secondary server, and using something like Traffic Manager, you can redirect your app for write purposes into the secondary server. But you do have read-only traffic, right? And so read-only traffic is really interesting because read-only traffic can occur obviously in the secondary. So if you want to set up Geo Replication and have your read-only traffic, remember, Anna, for example, a general purpose doesn't have a read replica. Remember, we talked about that, right? You only have that business critical. So let's say you need a read replica of general purpose. You could do Geo Replication and have that capability. So you notice here that your read-only traffic is directed into that secondary logical server, which again, it could be actually in the same region we're showing here in a secondary region. Now for managed instance, as an example, or it could be with database, but we show this kind of a little bit with managed instance because this is your choice. There's a good reason why it's called auto. In Geo Replication, you're responsible for updating connection strings when you do a failover for your read-write traffic, whereas in auto failover groups, that is being handled for you automatically. And in fact, the reason that's being handled is we have this listener concept for you to set this up so that that can be redirected properly. And you got a listener both for read-write traffic and for read-only traffic. But notice in here that you've got a multiple icons. It's called failover group for a reason, because multiple databases can be part of the group to fail over to the secondary, or you still have that same concept of having your read replica access on the secondaries as well. So if you kind of compare these a little bit side by side, you can kind of tell the differences here. So Geo Replication being a great option for you, but it says manual failover, does give you read replica capabilities, whereas auto failover groups, that's why it's called auto, are going to give you that automation. Now, one thing I should call out here, Anna, a little bit is that you do have the ability in these cases to ensure things are synchronized during like auto failover. Like there's even options you can configure, like how long should we wait to make sure you synced up your changes before you fail over. Or there's even stored procedures you can add into your application to ensure things get synchronized before you do that failover concept. So there are some aspects to these that we document how to do it. These diagrams look fairly complex, right? But it isn't as sophisticated as it looks. In fact, I actually think you should do a demo. Maybe I'll make it seem a little easier for this visualization I just showed everybody.
Yeah, definitely. Yeah, let's take a look at a demo of auto failover groups. And again, this is one that is available in the learning path. So if you want to go try it yourself and see how easy it is, I'm not going to step through all of the steps today, but you'll be able to see some of them. So let me just resituate my screen. So again, this is another notebook in Azure Data Studio. This is a PowerShell notebook. And you can see up to step 7. So basically what that means is there were 6 commands that got me all set up. Deployed the failover group, deployed the secondary server, decided which databases I wanted to sync, add networking access to both regions that are going to need to have access to it. That's an important part. And basically we're able to initiate a failover from here. Now what I also have, and let me see if I can do something there. Didn't quite work, but that's okay. But what we also have over here is a very simple Java application. And what it's doing is it's connecting to the read-write listener. And then it's trying to insert a row there. And then it's connecting to the read-only listener and trying to read that row that was just inserted and just reporting back at whether or not it was successful or not. So what I can do is I can first use this command, and it's the get AZ SQL database failover group. So in this case, this is for an Azure SQL database. The process is very similar for Azure SQL Managed Instance. And I'm basically saying, okay, for my, you can see it here, what I've defined as my DR server, what's the replication role? And I can see it's in the role of secondary. And now what I can do is I can use this switch command, so switch Azure SQL database failover group, and say, hey, I want the DR server to become the primary or the read-write. So now if I run that and I switch over and look at my Java application, what we should see is that for a certain time, and here you can see it, we're failing on our inserts and our reads as this failover takes place, and we actually switch under the hood what you're connecting to. And so we can see we'll get a few failed inserts and reads, but once we're back to being connected like we are now, we can see that without me changing anything in my application, we're back to being up and running. So a few things here. This is why it's so important to have retry logic in your application. And also auto failover groups having this read-only listener and read-write listener is so valuable. So again, just to confirm that we are now connecting on the read-write to the DR server, we can run that same command as before, getting the DR server's replication role and seeing that it is in the primary. Now in the exercises, you also have the opportunity to go ahead and fail back. And again, in the application, you would expect to see a similar behavior, some number of failures before going back to being successful. Now, one of the other interesting things that we won't do today, but you can do in the exercises, is to figure out how many read replicas you get from actually deploying this availability group, or sorry, this failover group. And it becomes an interesting question when you have, say, a business critical database and you deploy an auto failover group because, you have the readable from your main location region, and then from your failover group, you have the readable listener, but you also have another readable endpoint. So lots of options there. And you can see this failover occurred successfully as well. So that's auto failover groups. This is a fun exercise. I definitely recommend checking it out and just seeing how it all works, and seeing, you can even use the Azure portal if you want to kind of see those failovers taking place. So now that we've talked about some geo replication and auto failover groups, I think it'd be good to talk a little bit more about the databases itself and how do we keep them available and consistent.
Yeah, thanks, Anna. This is going to feel very engine heavy, so get ready for some hyper-focused engine stuff. But if you remember back on when we first talked about this entire exercise, all the entire training we've done, a lot of it was assessing SQL Server that you know and love today to what happens with Azure SQL. Again, it's the same SQL Server engine there, but there's certain aspects that you're used to doing in SQL Server that you want to know, is it still there in Azure SQL? Do I even still need to do it? So from an availability perspective, first of all, you can't set your database offline or emergency mode. You're like, oh, I need that. I've got to go do that. Well, why do you need to do that though? Because you're trying to do some sort of advanced repair typically. In fact, I did that my entire career with SQL Server. That's not necessary because of what we have in place from an availability and HADR perspective built into the service itself. Now, restricted user access is definitely allowed. So if you need that kind of type thing to kind of only allow certain people in to do certain things in the database, you can do that. And then if you want to do some advanced diagnostics though, and say you've got an application that blocks everybody and it looks like your SQL's hung, but it's really not, you can use a dedicated admin connection. We call it DAC. You're allowed to do that. And I've been able to demonstrate that before and use that with Azure SQL Database and Managed Instance. And then we'll talk in a second about this powerful capability I mentioned already once called Accelerated Database Recovery. This is on by default. And guess what? You can't even turn it off. We feel that important that we need that to maintain those service level agreements. So that's on there just built into the service itself. And we'll talk about in a second why that's powerful. Now, Anna, for database consistency, I kind of made it a career patching customers a long time ago, customers calling in, having a problem with their database, and not necessarily because SQL Server had a problem. It was typically with the IO system. And so consistency became a big thing to check and to fix. Keep in mind what we already told you. We have multiple copies within the environment of your data and your backups by default in the system. So the likeliness of like a hardware failure causing problems for you and not getting access to your database becomes very, very minimal. You can, though, run CheckDB. If you want to just check the logical consistency of your database, you're allowed to do that and take a look at that. You can't repair it because that would require you to put database in single user mode, which you're not actually allowed to do. So you can't repair things with CheckDB, but that's actually okay. Because consider this, we put database checks on by default, and if we detect a problem, in cases like in business critical, we can use the auto page repair functionality of availability groups to go back and online restore a page you don't even know it's actually happened. But also behind the scenes, we do a lot of monitoring of your system to make sure things are available. So any data integrity problems, we will actually monitor and get alerted to see if we need to help take action if something couldn't be corrected automatically. We mentioned already, like for backup, we do integrity checks, and we even do integrity checks to test restores of your database, so we're automatically backing up to ensure they have high integrity because we're using checksumming of the actual backups themselves. We even deploy things like lost write and stale read detection behind the scenes to look for very strange kind of like tangential type hardware type issues we've seen across the years. We have those on by default. And then look at this. We may actually go do a repair of your database and not even notify you if we determine there's no impact to your system. But if we think there might be impact to your application and we need to do some sort of repair operation or some sort of advanced restore of some redundant copy we have a very robust proactive notification system with our engineering team directly to you as a customer with your subscription to kind of help you out. So if you kind of put those together in between what's possible for availability reasons for you, but also what we do so much from an automation perspective to keep you consistent, it's a pretty powerful story.
Definitely.
Well, there wouldn't be any more powerful story than to talk about accelerated database recovery. And Anna, let's do something fun. Let's kind of do a fun exercise. Let's tell a story of Bob, helping customers in his career at Microsoft. And it kind of goes something like this. So There's this guy, have you heard this guy, Buck Woody, Anna? You ever heard him before? This guy, Buck Woody. So Buck, let's say he is running an application and we give him SQL access directly to run SQL commands. I don't know why we would even do something like that for Buck Woody, but he goes out and runs a transaction and he ends up accidentally deleting 1 billion rows in a table in a transaction, which is really bad, right? So because he does this operation, he's kind of blocked all the applications, which is actually bringing our business down. Now, Anna, you are kind of like a DBA, and you realize you've made a mistake to give Buck this kind of type access, but it's okay because you can kill his session. I know you probably want to take care of him, but you're going to kill his session. So you go in and kill his session. You think you've taken care of it. It goes in this rollback state, and you're like, "What the heck am I going to do?" You call me. Like, hey, you were on the phone with me, you and Buck. You're like, hey, Bob, what are we going to do now? What's going to happen now? We're in this rollback state. How long do we need to be in this rollback state? And I'm like, well, a while. It's going to take a while because it has to roll back. And so behind the scenes, though, on the phone is Elaine Dormal, our friend Elaine. He works with us. Now, Elaine read on the internet somewhere. You guys are talking to me, but he whispers to you, I can fix this. I learned on the internet, if I just crash SQL Server and we just like tear it down and just kill the process and bring it back up, it'll just recover and it'll be great. And so you're like, oh, Bob, sorry, we don't need to click. And I'm like, what's going on here? Do they still need my help? And so Elaine does this, and you guys are trusting Elaine, and you do that, and you bring it back up, and in the error log, it starts printing 1%, 2%, and you're both staring at Elaine now going, great, what are we going to do? Now, Pedro Lopes, our other colleague, he manages the transaction log, and this entire transaction log cannot get truncated. So literally you run out of disk space on the system as well because the transaction log goes out of control. This is disaster. Now, Buck started the disaster. It sounds like Buck, right? But you all contributed to this problem. Actually, it's not your fault. It's SQL Server's fault. Like, why do we even allow you to get in this situation? Along comes accelerated database recovery. In fact, I did a LinkedIn post in this last year. ADR saves the world from long recovery problems, right? And so it's really interesting on how this technology works. Let's talk a little bit about it, okay? Then we'll see a little demonstration. So first of all, from an ADR perspective, what we're going to do is we're going to use a persistent version store in the database, not the version store in TempDB. We're going to record versions in your database to make things faster. Now, it's independent of locking and isolation levels, so all that stuff just still works. Regardless of our versioning, we're doing this all the time. But here's the interesting thing. For SQL Server, for snapshots, we use versioning in TempDB to support the concept of snapshot. Here, we're using versioning for recovery and rollback purposes. Now, we get to take advantage of it, though, if you do a snapshot, but you still get read-committed isolation levels, even though we're using versioning. Now, rollback gets ridiculously fast. It's like so fast, you can't even imagine. That crazy scenario where you kill this session would just roll back immediately, which would be kind of nice, right? You wouldn't have to go crash SQL Server and call me and all that kind of stuff. In fact, under recovery, even if Elaine had done that, what happened so fast, you wouldn't even see a percentage showing in the error log because it's that quick. And then Pedro doesn't have to worry about anything because the transaction log gets truncated. It's not tied to this big, long, active transaction. And I know that sounds like way too good to be true. It's not for free. Like, what is going on here? But remember, accelerated database recovery is on by default in Azure for a very good reason. We believe that it will not greatly affect your application. And Anna, here's a great tip as a presenter for you. If people have questions like, does it require more space? Will it affect performance? The great thing to do is just point them to somebody else that's giving you the answer. So that link, people can research constant time recovery. It's a link in the deck as well. It's a white paper written by the developers who wrote the code. They wrote this very extensive paper as a kind of a computer science type paper because of the project they did. And we first did this in the cloud. We turned this on in all these databases in the cloud. And then in SQL 19, we made it a feature that people could actually use. And I think you're going to love it. If you go look at that paper, all these questions are going to be answered. And in fact, what's really cool is that for availability groups, it even makes it more powerful for failover and for read replica purposes. So this is amazing technology. One of the most innovative things I think we've done in the engine space in several years. So why don't I take a second perhaps and share my screen, Anna, and I'll show you a little bit of what it looks like.
Please.
Would that be okay?
Oh, yeah.
But I promise not to, get anybody in trouble like you or Buck or Pedro or Elaine or something like that.
Yeah, so let's not kill anybody or any session.
Or their session. Yeah, their session. Right. So, okay, let me know when you can see my screen.
I can see it.
Okay, so just for everybody's purposes, if you're using this demonstration won't work in Azure. You're like, well, why are you even showing us today? It's because it's on by default in Azure. So you can't see the differences between not having and having it because we're just fast. But if you wanted to try this, this is part of the SQL 19 workshop, which we have resources at the end to show you how to get all our workshops. And so this is a T-SQL notebook, kind of like Anna showed you some notebooks with PowerShell. I'm just using a pure SQL notebook. And one of the things I'm going to do, Anna, is I'm going to create a database. And Anna, if you get to come on and say that Tennessee Titans are all this great and I love them and so forth, I get to promote my Cowboys. So here's my database called Go Cowboys. And I've got a table of about 100,000 rows. So what I'm going to show you, Anna, is that what does this look like when you don't have ADR and you have ADR? In Azure, of course, in Azure, it's on by default. So let's come along here, and we're going to delete all the rows in the table that Buck Woody had done if it's turned off. And so we do this, it takes about 5 seconds, but we have an active transaction now that's out there. It's only 100,000 rows, but it still could affect us. And one of the things it could do is affect log usage. So you see here, Anna, that the log here is used at 91% because it's an active transaction out there. Now, I made this a simple recovery database in SQL Server. And if you did that, normally like a manual checkpoint could free up the log. But notice here, it doesn't free up much of the log. And again, it's because I'm using an active transaction. So I'm going to try a rollback. Instead of like killing the session, I'm just going to roll back this transaction. And you'll notice here that it takes about 11 seconds. Now, why is that? That's because we're using the standard Aries algorithms now, not ADR. And so for all those deletes, I got to go put in the log a bunch of inserts to compensate for what I did to support the concept of recovery for rollbacks. So that's why it takes 11 seconds. So during this entire time, I'm down, like I've blocked everybody, and the log can't be truncated, which is not a good situation. And again, if it was a billion rows, it could really take a long time. So I'm going to scroll down here and show you when I turn on this feature. In SQL Server, it's an opt-in for your database, where in Azure, of course, we're just doing this, by default. So let's go down here, do the same thing to delete our rows. Now let's go look at that log usage, which was important before. And notice here now that after a manual checkpoint, I'm even down to 7%. So, I was at 91 and 79 before because an active transaction was there. The active transaction doesn't affect this because I'm using versions in the database itself. Now, how fast is rollback? Let me scroll and just leave it right there, Anna. Do you want to take a guess of how long it took to do this? It took 11 seconds before.
Like
what do you think?
5
seconds? 5 seconds?
Yeah.
How about less than a millisecond? Look at this. This is how fast rollback is.
Wow.
Now, why is that? I mean, is that like a fake thing? Like, do I fake type in that text in there? I didn't do that. That's because in a rollback, all we have to do is mark a single record in the log as being aborted and mark the version aborted in the row, and that's it. SQL Server handles the rest of it. I've got another exercise somebody could do offline that if you go do the crash SQL thing, you can see where it took like 5 minutes to recover the database with undo recovery. When you're using ADR, it happens so fast you don't even realize. It just happens and the database comes back up. This explains again, Anna, why in Azure SQL we can do these SLAs though. Because we're using ADR, and even if you've got a long-running transaction or something, we can do a failover and get you up and running very, very quickly because ADR is in place by default in the system.
Wow, that's pretty powerful. And so this is on by default in Azure SQL. So there's nothing to do here except to just take advantage of it.
Exactly. And watch it fly.
Cool. Well, thanks for showing us that. That was pretty cool. I'm pretty impressed how fast it was. I'm gonna have to go try that myself, but not on Azure SQL because it's
fast.
Okay, so we've talked a lot about different capabilities when it comes to availability, and really the last thing we want to talk about is the task. So what do you need to do? Well, a big part of this is just understanding what all the different capabilities are and the implications. How does it affect your SLA? What is the SLA that you even need? And what are the various things that you might use in order to reach that SLA? Are you going to need long-term backups? And, is 35 days long enough? Is 2 years long enough? Figuring out those sort of things are going to be really important, as well as, what type of read workloads are you handling? How many read replicas? Do you want it like in business critical where you have the read replica all the time? Or is it more ideal for a scenario like Hyperscale where you don't necessarily have one all the time, but you can scale up to 4 when you need them? Lots of things to think about, even when we talked about Geo Redundancy or Geo DR, whether you're going to use Geo Replication versus auto failover groups. And then Bob, a big one I think people overlook is is your application ready? Can you give some pointers on what you might want to do there?
There's 2 things that stand out. You mentioned one of them, and that is retry type logic. But keep in mind this: today with SQL Server in your environment, when the computer is down, the server is down, or SQL is down, you're used to seeing a certain error when you connect to retry. Remember with our gateway system, the gateways could be up, but the SQL server is failing over. And you get an error there. It's not like a connection error. It's like, hey, you're failing over. So you need to get used to running in our environment and kind of see, do I need to handle certain types of errors a little bit differently to do that retry thing? Another cool thing, Anna, is that we have a new thing we just announced called DNS aliasing. So for like the GeoDR type scenarios, you can set up a DNS alias, and that could be directed automatically to the GeoDR. So therefore, you wouldn't have to change like the connection string of your application when we talked about that kind of thing. So there's a couple things from an app perspective. Mostly it's around the retry type logic, but check out DNS aliasing. We just launched that.
Yeah, that's definitely an interesting one. The only other thing I would add is, when you think about these geo situations and disaster recovery, it's great that, we have all these options for your database, but you might want to make sure you're doing the same
Mm.
exercise for your application because, for example, if you fail over to another region and your application is still in this main region, well, one, you're introducing a lot of extra latency that you might not have had to think about in the on-prem world. But two, if that region's down, maybe your app is down as well. So something to think about there. Bob, as people go to look and say, okay, am I up and running? What's the process for monitoring?
Yeah, just like in SQL Server, there's several things you might want to monitor. One of them could just be like, is a region or data center available that you've deployed to? Like, is the West US down or something because of a problem in the actual data center or something of that nature? But you also might want to see, is my server available? Is the database available that I have? What does it look like from a backup restore perspective? My database is getting backed up. What's the history of doing restores, some of that type of nature? You might want to see my replica status, right? What is going on from a replica perspective? You want to see, like, is it being replicated to? Is it being synchronized? Is it synchronized? And then also, if a failover occurred, you might want to find out some reasons behind that happened. So there's different things you want to monitor. And then we give you certain assets to do that in different ways. One through the Azure portal, one through like T-SQL, and one through CLIs. So if you think about the Azure portal, you can use like service health dashboard and feeds to not look necessarily at your specific server or instance, but the overall Azure SQL availability. So if you want to know, oh, hey, is East US having any problems for like all Azure SQL users? We have a way of showing that through this dashboard, and you can do feeds to kind of see that as well. But if you want to see specific health for your resource, we have something called resource health that you can look at in the portal to see, oh, it looked like your specific database wasn't available at 3:15 p.m. for a period of time. And here's some reasons behind all of that. And then Azure Monitor helps you with this as well. There's some things you can do to look at alerts and metrics and even do log analytics to get those kind of type events. Now through T-SQL, we have things, for example, Xevent. Like backup history isn't specifically available. You could use Xevent though with say managed instance to go look and see the history of what backups are being done. Although you can for long-term retention see some of those things. And even things like catalog views and DMVs give you other capabilities to look at things. You have just the basic sys.databases query to see what's the status, of my database. And then because anything you can do in the portal, you can do CLIs. You have As CLI, you have PowerShell, and even REST APIs to go look at these various aspects of failover reasons, replica statuses, server and database availabilities. You can even monitor this, Anna. You could even do PowerShell, for example, to go through and monitor all the statuses of my servers or databases and kind of see where they are. So it's a rich set of availabilities. And I wouldn't, I'd be remiss if I also didn't mention that we have management packs. Some folks are System Center users and they want to know, I like management packs. We have specific packs for Azure SQL Database and Managed Instance that were built for the cloud that help give you some of those rich capabilities you're used to seeing on SQL Server.
Awesome. Yeah. Thanks, Bob. This has been a great overview of all the different options. I'm going to put up the next knowledge check, but while people are taking a stab at that question, I wanted to ask you, last week you showed us some of this new stuff. I think it was Azure Monitor SQL Insights.
Yeah.
Do you think that's a tool? I know you mentioned Azure Monitor. Do you think that's a tool that people can use not only to monitor performance, but also availability?
Yeah, absolutely. Because there are certain metrics in there that apply to just the availability of things, right? They're not so much as performance driven. I think SQL Insights is more of a performance tool for you, but there could be things in that model that you could consume with log analytics or even through the portal we have that could help this overall process of saying how available am I and how things are getting replicated and so forth. So absolutely.
Awesome. Thanks. That's good to know because that's a really cool solution that I just started recently getting my hands on that one. Okay, let's take a look at this question. So it says, what methods can you use to monitor region and data center availability? So Bob, we've got a few answers in. It looks like most people are saying option D. Can you take us through this one?
Well, we did say that the Azure dashboard, right, has the ability, and we focus on the fact that it's about a region and data center availability. So you have that, but we also said you can get alerted and do feeds, right? things like text alerts and email alerts. We said that. So just by the fact that you can look at the dashboard and you can look at alerts, tells you that like it's got to be A and B for sure, right? Well, there is no A and B, but there's a D. So it just goes to make sense that D would have to be the answer because I can do alerting and the dashboard. So and we do this for an important reason. You might want to visually look at a dashboard, but wouldn't it be nice to get a text alert to say, hey, the East US is down. I better go look at something, right?
Yeah, definitely. And it looks like most people ended up getting that one. So
okay, cool.
Great job. Okay, we have one more question today. So this is the last knowledge check. We're going to step it up a little bit. This one is, which of the following is not a way you can monitor instance server and database availability? Bob, do you have any hints on this one? Because this one is kind of tricky. I think you actually came up with this question.
Yeah, I don't think so. Good try. This is an Anna special. There's a keyword in here that starts with an N, so I'd pay attention to that one. Looking at that keyword not is going to help give you some clue on what the answer might be. So yeah, make sure you focus on the word not and monitoring specifically. We're talking about individual resources here. That's kind of the clue, I think, if I would go through and look at the answer here. Awesome. But good try to put put a knowledge check on top of me. That's not the case.
I had to try. It looks like we've got a few answers on YouTube and also on Learn TV. Looks like people are leaning towards option A. Why don't you take us through it?
Yeah, we just talked about the fact that if you want to monitor your instance, your server and database, you had this resource health capability, right? That was a way to do it. That can't be the answer because we're doing a negative question, right? So that works. And then I said, for things you can do in the portal, you can do with CLI, right? With PowerShell and Ask CLI. So C and D are ways. They can't be the answer. So there's only one answer left, and that's Azure Service Health. And we're just trying to point out for you that that's more about the overall state of the service, which again, it does affect you and what you're doing. But if the overall Azure service is there, your database could actually be okay. So this is just a way to look at the overall health of a region or a data center and not specifically for your database. Just keep in mind, it's very important that you go out there and look at a data center problem, and it may not affect Azure SQL. It could be something that affects something unrelated to your thing. So if you get an alert to say, oh, East US has a problem, it may not be an Azure SQL issue. It may not affect you, but we are part of the Azure infrastructure. So there are other Azure resources like storage, networking, et cetera, that could impact your application. So it is important to monitor the health of services within the region you deploy.
Awesome. Yeah, I think that was a good question, but I also think everyone answered correctly. So
you probably, you went out there on one of those other things like you do, like in YouTube, and you just gave the answer, didn't you?
Oh no, I didn't.
Yeah. Yeah.
Sure. We got some smart people on the call.
I think we do.
So let's summarize what we talked about. So we started with backups. It feels like a long time ago because we've been so deep into availability, but we started with backups. We led into high availability through the different service tiers, including things like read replicas, including getting a higher SLA in some cases with zone redundant configurations or multi-AZ deployments. We also talked about how you can go geo, get geo distributed applications with things like Geo Replication, auto failover groups. We talked about trying to figure out how to make the right choices so that you meet the SLA that you desire. And then, Bob talked us through some different things you can monitor and different ways you can monitor. So, this is the kind of nearing the end. We've got some resources and some other things to share, but nearing the end of the series, we have one more episode left. Can you tell us, Bob, a little bit about what's next?
Well, we covered that meat and potatoes. This is the end of that section, right? Security, performance, availability, very core SQL things we need to talk about. When we first built this series, you came to me and said, is that it? And I'm like, yeah, that's it. And you're like, well, let's put it all together somehow. And so I'm like, I love that idea, Anna. So we kind of brainstormed together and said, how do we find a very creative way for you to take all this knowledge we built over the last 5 weeks and put it together, like kind of from a solution perspective? And then also, are there other stuff? Are there other things that we didn't cover that don't fit nicely in this meat and potatoes? So I think that would be a great idea next week, is to kind of find a way to wrap together everybody's knowledge and maybe even also talk about how to go bigger with Azure. we really kind of focused on how SQL works from an Azure SQL perspective and things that really are powerful for Azure SQL, but there may be more ways you can do more in the cloud. So we should sprinkle that in there as well.
Yeah, definitely. I think it's going to be a really fun week, and we'll keep it really engaging and put out some asks for you all to kind of participate with us. Before we go, we wanted to share some resources with you. We talk a lot about a lot of different things. So just to remind everyone, that first URL is going to take you to this learning path where you can get hands-on with availability and any of the other modules from the Azure SQL Fundamentals learning path. The second URL, SQL Workshops, if you go into that and select Azure SQL Workshops, you can also find other code samples, and more importantly to most people is the slides. That's where you can get these slides. That's where they're hosted. The Azure SQL Docs is a great place to find anything you're not sure about. Whenever I go to Bing with a question, I always type Azure SQL Docs and then the question, and it usually takes me right to it. If you like videos like this or hearing from us, Azure SQL for Beginners is a series Bob and I did last year. That's 61 episodes covering these topics, but more in like bite-sized chunks. So if you're like, oh, I really want to remember what the business critical architecture was, you could just go to that video because there's one video on that topic as opposed to having to rewatch this entire series. Also, shameless plug for Data Exposed. It's our show on YouTube and Channel 9. We go live on Wednesdays and we release new episodes on Thursdays. And then some books that have happened in the past year. Bob wrote a great book, Azure SQL Revealed, that is kind of along the same themes of this, really translating your SQL Server knowledge to Azure SQL. And then another book that myself and a few folks on the team wrote last year as well was around Azure SQL Database for developers. This dives a little deeper into Azure SQL Database just from a development perspective. So both two really great books to check out if you really want to learn more about these topics. Again, today what we covered was the availability module. So you can go to Learn Available SQL. That's the URL. And if we look at our schedule and you say, hey, I really wanted to know what you guys said about security, well, all of ours recordings are hosted at aka.ms/learnlive. And if you want the calendar invite for our last episode, it's going to be so sad not to spend my Mondays with you all. I don't know what I'm going to do, but is next Monday. So be sure to tune in. You get the calendar invite at this URL. And like Bob mentioned, it's going to be very interactive. We're actually going to take to Twitter, we're going to take to YouTube, and somehow we're going to get you guys engaged because we have some really challenging case studies, and we're going to look to you to help us find the answer. So definitely want you all to turn in to Learn TV next week. Bob, any final closing thoughts?
No, thanks, Anna. Thanks for being a part of this today. Great demonstrations. You did a wonderful job as always. Thanks everybody for tuning in. Listen, we think this is important stuff. You want to go past DP300, just go through this material. And people have told us they've been able to do that. Remember, this is just SQL, but it is the power of SQL. And we believe Azure is the best place to run SQL in the cloud. So I hope today's availability session has helped, kind of convince you that's the case.
Awesome. Yeah. Thank you so much, Bob. Thanks to all our viewers. Thank you. And we'll see you next week.
Bye.